Hello everyone. Under chemical properties of alcohols and phenols, today we will study about reactions due to breaking of CO bond. First, reaction with hydrogen halides. Alcohol reacts with halogen acid to form alkyl halides and water. The reaction. Different types of alcohol reacts under different set of conditions with different halogen acids. For example, if we take ethyl alcohol, a primary alcohol, reacting with a haloacid HCl in presence of anhydrous zinc chloride, it gives alkyl halide as ethyl chloride and water. Same primary alcohol, when it is reacted with hydroboric acid, it gives bromoethane and H2O. HBr is generated in situ when it reacts with concentrated sulphuric acid and NaBr. Similarly, the same primary alcohol, when reacts with hydroiodic acid, which is generated in situ as a part of reaction of phosphoric acid and NaI, it gives iodoethane and water. Now these are the examples where the same primary alcohols reacting with different type of haloacids under different set of conditions to give the respective alkyl halide. Thus, order of reactivity of halogen acids on alcohol is Hi is greater than HBr is greater than HCl. As the reaction involves the replacement of hydroxyl nucleophile by a halide nucleophile, the dissociation energy of Hi is least and increases from Hi to HBr and HBr to HCl, and hence Hi can readily give the iodide nucleophile than HBr and HCl. So the order is as shown here. When we take the different types of alcohols, then reactivity of alcohols with haloacids is tertiary is greater than secondary is greater than primary. Second, reactions with phosphorus halide, that is PCl3 and PCl5. Alcohols react with phosphorus pentahalides and phosphorus trihalides to form alkyl halides. General reaction. Example, first, when ethanol reacts with phosphorus trichloride, it gives chloroethane and phosphorus acid. Reaction. Second, when ethanol reacts with phosphorus pentachloride, it gives chloroethane and phosphorus oxychloride, POCl3. Reaction. Third, dehydration of alcohols. Alcohols undergo dehydration to form alkenes on treating with concentrated sulphuric or phosphoric acid or catalyst anhydrous zinc chloride or alumina. General reaction. Reaction gives more substituted alkene as a major product, that is, following Sidzeff rule. First, consider primary alcohols. In this, ethanol, when treated with sulphuric acid at 443 Kelvin, it gives ethene and water molecule. This is the experimental view how the ethene is collected on dehydration of ethyl alcohol. Secondary and tertiary alcohols. Secondary and tertiary alcohols are dehydrated under similar conditions. Reaction. The concentration percentage in case of secondary alcohol and tertiary alcohol is different. Also, the temperature difference can be seen. Thus, the order of relative ease of dehydration of alcohol is tertiary is greater than secondary is greater than primary. This is because tertiary carbocations are more stable and therefore easier to form than secondary or primary carbocations. So, tertiary alcohols are easier to dehydrate. Distinction between primary, secondary, and tertiary alcohols can be done by the following four tests: oxidation, reaction with copper, Victor-Meyer test, and Lucas reagent test. Out of these four, we have already discussed about Lucas reagent test in our previous videos. So right in this, we will be discussing about the first three reactions. First, oxidation of alcohols. Oxidation of alcohols involves formation of carbon-oxygen double bond, the cleavage of an OH bond and CH bond. These reactions are also known as dehydrogenation reactions. General transformation. Alcohols can be oxidized by using common oxidizing agents like diluted NO3, acidified K₂Cr₂O7 potassium dichromate, chromium trioxide CrO3, and acidified or alkaline K₂O4. Oxidation of primary and secondary alcohol leads to the formation of aldehyde, ketones, and carboxylic acid, while tertiary alcohol does not undergo oxidation easily. First, we'll study about oxidation of primary alcohols. When primary alcohols are oxidized using common oxidizing agents K₂Cr₂O7, it first gives an aldehyde which gets further oxidized to form carboxylic acid with same number of carbon as in alcohol. General reaction. An example. In this example, a primary alcohol ethanol is taken, which is having 2 carbon in it. When oxidized using potassium dichromate and sulphuric acid, it first gets converted into ethanol, carrying 2 carbon atoms, which further get oxidized to carboxylic acid, that is ethanoic acid, again carrying 2 carbons. So the number of carbon in from alcohol to acid transformation is same as it is in the previous alcohol. The best reagent for obtaining an aldehyde from primary alcohol is PCC, pyridinium chlorochromate. PCC oxidizes primary alcohols to aldehydes without further oxidation to carboxylic acid. Example: propane-1-ol to propanol. Oxidation reactions of secondary alcohol. Secondary alcohol on oxidation with chromic anhydride or potassium dichromate and dilute sulphuric acid gives ketone with same number of carbon atoms. Ketone resists further oxidation as it involves breaking of carbon-carbon bond. The reaction, tertiary alcohols, these are difficult to oxidize due to the absence of alpha hydrogen atom. Reaction,
Copper. When vapors of various types of alcohols are passed over hot copper, following reactions are observed. Reactions. In this, when vapors of primary and secondary alcohols are passed over copper at 573 Kelvin, dehydrogenation takes place and an aldehyde or a ketone is formed, while tertiary alcohols undergo dehydration to form alkene. Another method for distinguishing between primary, secondary, and tertiary alcohol is by Victor Meier's test. Following sequence of reactions takes place. The alcohol under examination is treated as first with red phosphorus and iodine, when the hydroxyl group is replaced by iodine to form the corresponding iodide. The iodide is then treated with silver nitride to get the corresponding nitroalkane. Nitroalkane is treated with nitrous acid, and finally the solution is made alkaline. Different types of alcohol give different observations. Primary alcohol gives blood red coloration, secondary alcohols gives blue color, and tertiary alcohols do not produce any color to the solution. This way we distinguish between primary, secondary, and tertiary alcohols. With this, reaction due to breaking of CO bond is completed. Thank you.